Right now, as you are watching this, tornado sirens are going off across 3 separate states at the same time. In Texas, a violent wedge tornado touched down near Lubbock, tearing a damage path more than a mile wide across open farmland and rural communities. In Oklahoma, the National Weather Service has confirmed multiple tornadoes on the ground simultaneously in Pawnee, Osage, and Payne counties. And in Missouri, residents near Joplin, a city that still carries the memory of exactly what a direct hit looks like, watched a wall of rotating cloud drop out of a supercell and begin pulling structures apart across the Missouri-Oklahoma border. 3 states, one afternoon. And the Storm Prediction Center has placed more than 23 million Americans under an active tornado watch, stretching from the Texas Panhandle all the way to the Mississippi River. Weather balloons launched this morning recorded wind shear values that operational meteorologists described as among the most extreme they have documented in over a decade. This is not isolated. These outbreaks are connected, driven by a specific collision of atmospheric systems that is locked in place over the central United States right now. Drop a comment below. Have you ever personally been caught in a tornado or lived through a major outbreak? Tell me exactly where you were and what it felt like. If you want to be the first to know every time something major like this develops, subscribe. It is completely free. A thumbs up also helps enormously. Let us go for 5,000 likes on this one so the algorithm actually shows it to people who need to see it. Today we are going to break down exactly what is going on, where it is most dangerous, and whether things could get even worse. No guessing, no dramatizing, just the facts, the science, and the real stakes. Now, let us get into it. To understand what is happening right now, you need to go back to the morning it began. On July 28th, at approximately 6:47 in the morning Central Time, the National Weather Service office in Norman, Oklahoma, issued what is called a mesoscale discussion. If you have never heard that term, here is what it means. A mesoscale discussion is the document that forecasters send to each other before a tornado watch is formally declared. It is the quiet internal alarm of the meteorological community, the warning before the warning. The language in that morning's mesoscale discussion stood out even to experienced forecasters. It described a particularly dangerous situation developing along a dry line that had sharpened overnight across the Texas Panhandle. A dry line, if you have not followed severe weather reporting before, is the precise atmospheric boundary where bone-dry desert air flowing in from New Mexico and Colorado collides with warm, moisture-loaded air that has traveled hundreds of miles north from the Gulf of Mexico. When those two air masses meet at the right angle, with the right wind pattern overhead twisting in exactly the right configuration, the atmosphere does not produce ordinary thunderstorms. It produces supercells. And supercells, under the right conditions, produce tornadoes. By 9:15 in the morning, 3 supercell thunderstorms had already formed along that dry line, and were tracking northeast at between 40 and 50 miles per hour. At 10:22, the first tornado warning of the day was issued for Floyd County, Texas. The rotation was confirmed not by a storm spotter on the ground, but by dual polarization Doppler radar out of the Lubbock National Weather Service office, a technology capable of detecting the debris ball lofted by a tornado before any human being on the surface even reports it. That debris ball signature appeared at 1,300 feet above the ground. That height told meteorologists this was not a brief, disorganized spin-up. This was a structured, violent vortex with a well-defined condensation funnel reaching toward the surface. That changed fast. By 11:09, the Floyd County tornado had widened to an estimated 1.25 miles on the ground. Vehicles on Farm-to-Market Road 378 were thrown into adjacent fields. A grain storage facility northeast of Lockney was stripped to its concrete slab. Preliminary damage surveys placed the storm at EF3 or stronger on the enhanced Fujita scale, wind speeds estimated between 136 and 165 miles per hour. To put 150 miles per hour in context, at that intensity, a standard wood frame house does not simply lose its roof. The walls fail inward. Interior rooms are exposed to the full rotational force of the vortex. What was standing at 11:08 is rubble by 11:11. But here is the part that changed the entire geographic scope of this event. While Texas was being hit, the parent supercell complex had reorganized into what meteorologists call a quasi-linear convective system across central Oklahoma. Unlike a classic supercell, which produces tornadoes from a single rotating updraft column, A quasi-linear convective system can embed multiple rotating circulations simultaneously along a squall line spanning hundreds of miles. By 12:36 in the afternoon, the Norman Forecast Office had active tornado warnings covering Pawnee, Osage, Payne, and Creek counties at the same moment. 4 separate counties, simultaneously. First responders were receiving calls faster than dispatch systems could process them. In Pawnee, a confirmed tornado crossed U.S. Highway 412 and damaged at least 11 structures across a quarter-mile path. In Payne County, a brief EF1 tornado touched down within 2 miles of a rural school with students still in class. The children were already in the basement. The structure held. The margin was measured in feet. The system moved east. By 2:15 in the afternoon, the Storm Prediction Center upgraded the overall threat level to high risk. High risk is the rarest designation in the entire U.S. severe weather categorization system. It is issued on average fewer than 4 days per year across the entire continental United States. When the Storm Prediction Center says high risk, they are telling every emergency manager in the affected corridor that violent long-track tornadoes rated EF4 or EF5 are not just possible, they are likely. At 3:40 in the afternoon, a confirmed large tornado was on the ground in Newton County, Missouri, moving northeast at 61 miles per hour. Newton County sits immediately southwest of Joplin. The people of Joplin did not need to be told what that proximity meant. Joplin had already absorbed the worst that kind of storm can deliver. On May 22, 2011, an EF5 tornado struck the city directly. 158 people died. More than 1,000 were injured. 8,000 structures were destroyed or severely damaged. The damage path ran 6 miles through the center of the city. At its widest point, the path of total destruction stretched to 3/4 of a mile. The National Weather Service later documented peak wind speeds in the core vortex in excess of 200 miles per hour. So, when tornado sirens activated in Joplin at 4:03 in the afternoon on July 28, 2026, the residents did not debate. They went underground. The city's years of post-2011 investment in public shelter education, community storm shelter infrastructure, and embedded emergency culture compressed response time from warning to shelter into minutes. The tornado tracked north of the city center. Its outer circulation clipped the southwestern neighborhoods. Preliminary surveys indicated EF2 intensity, enough to remove entire roofs, shear mature trees at the base, collapse carports over vehicles. No fatalities were recorded inside Joplin's city limits, but no one in that city called it a close call without meaning it. In Lawrence County and Christian County, Missouri, the same system continued northeast through the evening hours, downing power infrastructure across 37 miles of rural roads and cutting cell connectivity to several isolated farm communities. Emergency crews could not reach portions of the damage corridor until well after dark. National Guard logistical assets were placed on standby. By 6 in the evening, the confirmed tornado count for the outbreak stood at 26. Storm survey teams working through the following day would push that number significantly higher. Now let us explain exactly why this happened, because the atmospheric setup that produced this outbreak is specific, measurable, and one that the scientific community saw building days before the first tornado touched down. The engine of every major Great Plains tornado outbreak is a phenomenon called vertical wind shear. Not the ordinary directional shifts you feel in a changing afternoon breeze. Deep, structured, layer-by-layer wind shear, extending from the surface all the way to 40,000 feet in the atmosphere. On July 28th, here's what that actually looked like over the central United States. At the surface, warm and humid Gulf of Mexico air was streaming northward across Texas and Oklahoma at 20 to 30 miles per hour from the south-southeast. At 10,000 feet above that surface layer, winds were already blowing from the west-southwest at 50 miles per hour. At 30,000 feet, the jet stream was overhead at over 100 miles per hour from the west-northwest. 3 distinct air masses, 3 different directions, 3 radically different speeds. To put that in context, imagine you are holding the bottom of a long towel fixed firmly to the floor. Someone pulls the middle section to the left. Someone else whips the top section hard to the right. The towel does not lie flat. It twists into a horizontal rotating tube. In the atmosphere, that rotating tube of energy is called horizontal vorticity. When a supercell thunderstorm's updraft, which can be moving upward at 100 miles per hour or faster in the most intense cells, intercepts those horizontal rotating tubes and tilts them into a vertical orientation, the spinning energy transfers directly into the storm's rotating updraft column. That column is a mesocyclone. A mature mesocyclone, given enough low-level convergence and moisture, can stretch a rotating vortex of air downward toward the surface. That downward extension is a tornado. But here's the thing that makes the central United States uniquely and almost incomparably vulnerable on the global scale. This is the only place on Earth where all of these ingredients reliably converge in the same location at the same time. The Rocky Mountains strip the moisture out of any Pacific air approaching from the west, leaving dry air in their lee. The Gulf of Mexico pumps warm, humid air northward with no topographic barrier. There is no mountain range between the Gulf Coast and the Canadian border on the American continent. And the jet stream, in its summer season configuration over North America, sits precisely over the area where those two air masses collide. The Europeans call a day like July 28th exceptional. In Oklahoma, they call it the season. If you follow tornado research at all, the name Tornado Alley probably already rings a bell. For most of the 20th century, that term described a corridor centered on western Texas, Oklahoma, Kansas, and Nebraska, the zone of most frequent violent tornado activity in the world. But research published over the past decade by meteorologists at Iowa State University and the National Severe Storms Laboratory has identified what scientists describe as a measurable eastward migration of the most tornado-active zones in the United States. States like Missouri, Tennessee, Arkansas, and Mississippi are now recording increasing tornado frequency, and critically, those tornadoes are striking communities with substantially less preparedness infrastructure than traditional tornado alley states. Older housing, fewer community storm shelters per capita, less cultural memory of what a direct hit requires in response time. Scientists currently do not point to a single confirmed cause for this shift. Warming Gulf sea surface temperatures, alterations in jet stream positioning, and changes in moisture transport pathways have all been proposed as contributing mechanisms. The long-term data, however, is not ambiguous. The affected zone is expanding east. Keep an eye on convective available potential energy readings across the region too. CAPE, the measurement of the fuel available to thunderstorm updrafts, reached 4,000 to 5,000 joules per kilogram across the outbreak corridor on July 28th. The climatological average for a significant tornado day in the southern plains is approximately 2,000 joules per kilogram. The atmosphere that afternoon was running at more than double the fuel load of a standard severe weather event. These are not just meteorological data points. They are the difference between a community that walks out of a tornado outbreak intact and a community that does not. And the contrast between what happened in different areas of this outbreak makes that difference visible in human terms. In Joplin, Missouri, the moment sirens activated, residents moved. They went underground. The investment that city has made since 2011 in community-funded storm shelter rebates, in public education campaigns, in embedding tornado response behavior into the identity of the city itself, compressed the response window to minutes. Wireless emergency alerts reached every cell phone in the warning polygon within seconds of the National Weather Service issuing the tornado warning. The tornado passed. Joplin had damage. Joplin did not have fatalities. That is not luck. That is infrastructure. Contrast that with what researchers have documented across the expanding tornado-affected zones in the Mid-South and Southeast. A 2023 study published in the journal Weather, Climate, and Society found that mobile homes account for approximately 1/3 of all tornado fatalities in the United States, despite housing only about 6% of the American population. Fatality rates in mobile homes during EF2 and stronger tornado events are statistically 23 times higher than in site-built structures with basement access. 23 times higher. In rural portions of Missouri and eastern Oklahoma, directly in the path of July 28th's outbreak, concentrations of mobile home communities without accessible community storm shelters created the highest risk zones of the entire event. In at least 3 counties, emergency managers later described coverage gaps in rural cell networks that delayed wireless emergency alert delivery until after tornado touchdowns had already occurred in those areas. The warning system worked. The infrastructure did not reach everyone in time. The difference between what happened inside Joplin's city limits and what happened in rural corridors 30 miles away is not a meteorological variable. It is a policy variable. It is a housing stock variable. It is an investment variable. The human geography of tornado vulnerability in the United States is as real and as measurable as the atmospheric dynamics driving the storms themselves. The National Oceanic and Atmospheric Administration reports an average of approximately 70 tornado-related deaths per year across the United States over the past 2 decades. That average conceals enormous disparity. Years with major outbreaks reset the statistics in a single afternoon. 553 deaths in 2011, more than 90 in a single multi-state event in 2024. The communities absorbing those fatality spikes are almost invariably the same type of community: rural, lower income, without basements, without shelters, without institutional memory of what a direct hit demands in response time and response behavior. There is also a psychological dimension to this kind of near-miss event that rarely gets addressed in real-time coverage. Research from the University of Alabama's Severe Weather Institute, which has tracked post-tornado community recovery for over 15 years, found that populations within the near-miss track of a major tornado, communities that watched a mile-wide vortex pass within 2 or 3 miles, show elevated rates of post-traumatic stress and what researchers call action paralysis during subsequent warning events. Some survivors of near-miss events freeze the next time the sirens sound. Some go outside to look. The fear, paradoxically, can make people less responsive the second time around. That psychological reality is exactly why meteorologists and emergency managers invest so heavily in clear, specific, timely warning language. Not just technically accurate warnings, but warnings that translate fear into shelter behavior rather than paralysis. In this outbreak, the Storm Prediction Center's high-risk designation, issued more than 12 hours before the worst tornadoes touched down, gave emergency managers across 3 states an unprecedented lead time window. Tornado shelters at schools, public buildings, and community centers across the corridor were unlocked and staffed before the first supercell formed. Each additional minute of warning lead time measurably reduces fatality rates in tornado events. The national average tornado warning lead time is 13 minutes. On July 28th, for communities that received and acted on the high-risk messaging, effective lead time was measured in hours. The difference between 13 minutes and 12 hours is not a meteorological statistic. It is the number of people who come home. The question now is, what comes next? And the answer from the meteorological community is not reassuring. The upper-level trough that organized the jet stream over the central United States on July 28th has not fully dissipated. It remains anchored in place. Weather modeling from the Global Forecast System and the European Center for Medium-Range Weather Forecasts, as of the morning of July 30th, continues to show elevated severe weather potential across the same general corridor through the end of the current week. This is what meteorologists call a multi-day event. Multi-day events are significantly more dangerous than single-day outbreaks because they exhaust the resources of emergency response systems before the final and often most dangerous phase of the pattern arrives. The Storm Prediction Center's Day 2 and Day 3 outlooks, as of this recording, show enhanced to moderate risk designations across portions of Arkansas, Tennessee, Missouri, and the lower Mississippi Valley. The same CAPE values and wind shear parameters that drove the July 28th outbreak are rebuilding over those areas right now. Keep an eye on the next mesoscale discussion out of the Norman, Oklahoma office, that is, the document that signals forecasters are moving toward the next round of watches. What scientists are also monitoring is the role of anomalous moisture retention across the Missouri River Basin. River flooding and ground saturation across Missouri, Iowa, and portions of Illinois is keeping low-level humidity values significantly elevated above seasonal norms. When that boundary layer moisture anomaly combines with the ongoing Gulf transport, you get an atmospheric fuel load that forecasters associate with major outbreak potential, not routine severe weather. The dryline position across the Texas Panhandle and eastern New Mexico is also being tracked closely. If that boundary mixes eastward faster than current models project, which it frequently does in late July heat, the next supercell initiation zone could shift east of the Interstate 35 corridor, directly into communities that have not yet finished assessing damage from July 28th and have not yet restored full emergency response capacity. The longer-term picture is something the research community is actively investigating. Multiple peer-reviewed studies published in Nature and Geophysical Research Letters over the past 5 years have examined the relationship between Gulf of Mexico sea surface temperature variability, changes in the Northern Hemisphere jet stream, and the frequency of extreme tornado outbreak events. The findings are complex, but a pattern is emerging in the most severe end of the distribution. The highest risk outbreak setups, the high-risk days, the days with multiple EF4 and EF5 tornadoes tracking for hours, appear to be occurring with increased frequency on the far tail of the event spectrum, even in years where the total count of reported weak tornadoes does not increase dramatically. Scientists generally do not conclude that this single outbreak or any individual event can be attributed directly to climate variability. The tornado genesis process involves spatial scales and atmospheric interactions too fine-grained for current climate models to fully resolve. But what atmospheric scientists are saying, with growing confidence, is that the boundary conditions creating the most explosive outbreak potential, the moisture loading, the jet stream positioning, the shear profiles, are being shifted in directions that could favor increasingly extreme events in the decades ahead. What emergency management agencies are requesting right now, in direct response to this outbreak, is increased public adoption of two specific behaviors that consistently save lives and remain consistently underutilized across the American population. First, identify your best shelter option before a warning is issued. Right now, while you are watching this, not when the sirens are going off. The lowest floor of the most substantial structure you have access to. If no basement exists, an interior room on the lowest floor, away from windows. Second, understand the difference between a tornado watch and a tornado warning. A watch means atmospheric conditions are favorable for tornado development. A warning means a tornado has been confirmed by radar or by a ground observer. Too many people treat both with the same level of urgency, or neither with enough. The watch is when you move to readiness. The warning is when you move to shelter. That distinction, clearly understood and correctly acted on, is not a minor technical point. In a fast-moving tornado event, that distinction is the difference between a shelter decision made with 3 minutes of lead time and a shelter decision made with 30. Here is where the science leaves us, and we have to be direct about what it actually says. Is the central United States witnessing the beginning of some unprecedented atmospheric era unlike anything in recorded history? No, scientists do not have evidence supporting that conclusion. Tornado Alley has always been Tornado Alley. Supercell thunderstorms have been producing violent tornadoes across the Great Plains since long before any weather service existed to document them. The worst single-day outbreak in recorded American history occurred in April of 1974. The deadliest tornado season in modern records unfolded in 2011. Neither of those events required any external forcing beyond the baseline physics of the atmosphere to explain. The atmosphere is fully capable of producing catastrophic tornado outbreaks on its own. It always has been. The most realistic and immediate danger from what is unfolding right now is not the emergence of some new kind of tornado. It is more specific than that. It is that the expanding geographic zone of severe weather activity, the documented eastward migration of high-risk outbreak conditions into communities with less preparedness infrastructure, less shelter access, and less cultural memory of tornado threat than traditional Tornado Alley states, means that the same meteorological event produces substantially more human harm than it would have a generation ago. Same storm, different community, radically different outcome. That is the gap that matters. That is the gap that emergency planners, housing policy researchers, and operational meteorologists are actively working to close right now across every state that absorbed damage on July 28th, and across every state that remains in the active threat zone as this pattern continues. Drop a comment and tell me, have you ever personally lived through a tornado or been near a major outbreak? Tell me where you were and what it was like. I read every one. And let us hit 5,000 likes on this video so the algorithm puts it in front of people in the current threat corridor who still need to see it. If you are in Texas, Oklahoma, Missouri, Arkansas, or Tennessee right now, your shelter plan needs to be ready before you go to sleep tonight. This event is not over. The pattern is still in place. See you in the next one.